So it's week 12, part 2. We've set up our API, and we've tried testing some of these endpoints in the scaffolded controller. So what we want to do now is set up our database connection. So there's a few steps we need to take in order to do this. So let's open up our app settings file. And before our last curly brace, we're going to add a connection strings, and that's plural, just like our web.config, our connection strings node. Connection strings is plural because we could conceivably have multiple connection strings in one application, not limited to connecting to only one database. So in JSON format, we are going to set up our default connection. That's been highlighted. Now, for the database connection, this we can actually copy and paste from our web.config file in the music project. So you can either grab it from your own web.config, or you can go into my repository on GitHub, grab the connection string value from that web.config file. So I'm going to go to my music store project, the web project. I'm going to open up web.config, just open it with my text editor. So what I need is this. I need from the beginning, where it starts with data source, all the way down up to and including the password. So it's got the data source, so there's our server name, the initial catalog, which is the database name. Persist security info is true, and my user ID and password. I don't need those last two parts of the connection string. Multiple active result sets equals true and app equals entity framework. We don't need those. So I'm just going to exclude that part of the string. So right from the beginning up until and including the password, I'm just going to copy that. And I'm just going to dump it in between those quotes in my app settings.json. So I don't really care if you use your database or if you use mine for this. So I'll just paste it in here. Password, user ID, persist security info, initial catalog, and data source. Again, you can kind of see where my cursor is flashing. That's where you can stop copying from. So now our next step is we're going to manually create a database connection class. The entity framework wizard did this part for us in our web application. It created the music store model. So we'll look at that file, but we're just going to build our own. Because in .NET Core, it's a little bit different. So we don't have a models folder. We want to create one. So if I just right click on my project name and choose add, in the context menu, I have new folder. So let's create a new folder called models. Yes. Everything's going to be Pascal case when we're in the Microsoft world. The new folder called models. And then inside of here, we're going to add a class. And just like in our web app, we'll call it music store model. That's our database connection object. Now, this isn't a regular class. This is a database connection class, so it's going to inherit from the context, which Visual Studio doesn't understand. So in this case, it's suggesting a reference. We need to reference entity framework core. I'll accept that suggestion, which will add a reference up on line 1. So you could manually add the reference on line 1, easier just to click and let Visual Studio make it for us. Right? So we now have a reference to Entity Framework Core, and our object is of type DB context. Now we're also going to need one NuGet package. So the Entity Framework Core library is here, but there's a specific library for interfacing a core application with SQL Server, and we need to install that package. Okay. So if I go to my NuGet package manager and click on Browse, what I want is Microsoft Entity Framework Core .SQL Server. This one. 12.9 million downloads. We want to add this package. Basically, any .NET Core app that uses SQL Server, you need this package. So I'll just click on this, choose my project. I only have one project here. So it says it's not installed. We'll install the latest stable release published a couple months ago. So we'll just install that package. Right, it has all these dependencies, so it wants me to accept the licensing terms for all of them. All of these are created by Microsoft. They're safe. So I'll just accept. Like I said, it's pretty lightweight. So it's done already. It just takes 1/10 of a second to install. Exactly what you see in this search text box. So Barry, do you see what you see up here? Microsoft.entity-framework-core.SQL Server. Okay, as long as you can see it, you can then select it. Just click on it, click your project, and install. This is all we're going to need. We don't need any other NuGet packages. Blind acceptance. Okay. So now what we need to do is two things. I'll actually just open up, just for fun. We can have a look at our music store model. So this is what was generated by the Entity Framework Wizard. It made these references. It created, so we had a constructor where it sets up the base and it knows to read our default connection from web.config. And then we had these references to each of our models, right? And any relationships. So all this code was auto-generated. So we're kind of hand coding a similar, like a .NET Core version of this. But we're only going to work with the albums model. We're not going to worry about the other models. So we do need a constructor. Format's going to be a little different. In this case, we've got to set out the database context options. So this is kind of the core version of this .NET framework statement. So the options that we're going to populate will be the name of the connection string. We also have to specify what type of database is it. So we have to specify that this is SQL Server, because we're not limited to SQL Server. We could connect to Oracle, DB2, Firebase, something else. So there's our constructor. The other thing we'll need actually, sorry, we'll come back to this. We'll finish the database part first. We are going to need this line as well, the list of albums, so that our database class knows what an album object is, so it can perform create, read, update, delete. So 3 steps down. Set up the connection string, install the NuGet package, create the database connection class with the constructor. Step 4 is we need to configure this, and that happens in this startup file. So if this is built in, this is one of the few files in our template. And in here, there's a method called configure services. It gets called by the runtime, and it's used for adding services to the controller, to the container. So this is where we basically provide the options to our database connection class. So this is where we read our default connection out of our settings. Then we're going to set the options on our database connection class. So there's 2 options it needs. It needs this DB variable that holds the connection string, and it also needs an option saying what kind of database it is, which is SQL Server. We're going to call an add DB context method. We're setting use SQL Server option, and that's where we pass our connection string in. We've got 2 errors. This is expected. This just suggests we're missing some references. We need to make this work. So music store model, it doesn't know what it is. So we just add a reference to the model's namespace. So I'll just mouse over, click on the little code hint, and it's suggesting, hey, if you want to use the music store model class, reference the model's namespace. So I'll just accept that. Right, error goes away. It adds a reference up on line 5. Or I could manually put that reference in. I'll let Visual Studio write the code. One more reference here. Doesn't know what use SQL Server means. Again, just a reference that's missing. We now just need to reference Entity Framework Core. If I add that reference, error's gone. So this method configures the context for connecting to SQL Server. So it's added this reference on line 10, this reference on line 5. So now we can build. So right now, our site is configured to use the database. Those are all the steps. Connection string in our app settings.json, install the package, create the database connection class, and configure it in startup. So now we should be ready, just about ready to build a model and controller. So let's add an album. We'll add a new class in models. We'll add a new class called album. We scaffolded this model before. We can pretty easily hand code it. It's pretty simple. So here's our class. We'll just set out the public properties with getters and setters. So we've got an ID. Title. artist in German. We can also add some of our validation here. So if someone's going to call our API, we still want our validation rules in place. So for example, they can't create an album with no title. They can't create an album with a negative price. So we'll add a few of our annotations here. So this is our key field. Title is required. Our price is range. Now, it doesn't like these annotations. In our web project, these worked. But here it's just telling us, hey, are you missing a reference? Just reference system component model.annotation. When we scaffold the models in our web project, that reference is already there. If we're doing this manually, we got to add the reference ourselves. So again, here was our scaffolded model. So it already has this reference. And it just automatically pulled this stuff from the database. There's one other line of code we need to add here. By default, the way MVC naming conventions work is our models are singular and it expects our table names to be plural. In this case, the database we actually have, our table name is actually singular, so we need to explicitly provide the name of the table this model is mapped to, and it's also singular. So we'll want to copy this line into our model as well. And missing reference. Just accept. So we've got to make a reference. It's a subclass of the data annotations library, data annotations.schema. I'll just accept that reference and adds to line 4. I mean, we could try to just copy this whole model in, but we have a whole bunch of other stuff in the from the scaffolding like this that we probably don't want in our API. So that's why I've manually recreated it. So there's our model. We also need, our database class needs a reference to this. Again, here was our scaffolded database class. It has this DB set of all the objects so that it can perform create, read, update, and delete. So we don't necessarily need the word virtual, but we do need a reference. It's a reference to the album model. But so now our database connection class is aware of the album, knows what an album object is, and it can work with it. So there's our setup. You will need to go through this same setup for assignment 3. Create the empty .NET Core API, add your connection string, add the new get package, create and configure the database connection class. It is. So now we should be able to create an album's controller with get, post, put, and delete methods that we can then test out. So under controllers, I'm going to add a new item. Oops. I want to add a controller, and I'm going to pick this one, an empty API controller. And I will call it albums. So we're going to write 5 methods, 2 get methods, a post, a put, and a delete. And as we write them, we'll use Postman to test them out. First thing we need is our database. Doesn't know what the music store model is, so just like in our web controllers, we need a reference to the models. So our controller can use our model. We'll just add the reference. Or you can add it manually, doesn't matter. And now we need a constructor. So we're using dependency injection like we did with our mock, right? We get a database connection object passed in, and that instantiates our database connection whenever we're using this controller. And we're making this public within this class. So all the methods can use that same database object. First, we want to make our API our get method that's the equivalent of an index. It's going to give us a list. So we'll declare it as HTTP get. What return type will this method have? The method's going to be called get, no parameters. We need to define a return type. What do we want back when someone calls our API/albums? Close. Right, we want a list of album objects. So in this case, we'll return an enumerable of type album. Now we're just writing a query the way we did before. That's a pretty easy method. Run the query, return the list. We're not returning a view, we're just returning the raw data. And by default, the format's JSON. We don't have to parse it, convert it, serialize it at all. So we can actually test this in a browser or through Postman, doesn't matter. So if I go to Postman and just replace this API/values with API/albums, make sure my method is get, let's send the request. There we go. If I click on pretty, there's our JSON. So any other application now can consume this data. If we publish this to Azure, we could open up Android Studio and build an Android app that makes an HTTP request to this endpoint, grabs the list of albums, and then we could bind that to, say, a list view control in an Android app. We could do pretty much there's no limit to what we can do with it, right? We're making it public in this case. Anybody can take this data and do what they want with it. So there's all our data ordered alphabetically in JSON format. So there's one of your 5 methods for your assignment. Done. Now let's write the equivalent of the details method. It's still get. It's still the same URL. We just stick an ID on the end of it. And that represents our details method. We'll declare it as HTTP GET with parameter. The server knows this is not another method name. That last value is a parameter. What return type should we have here? Okay. Let's return an album. What code do we need to take that ID that comes in and return matching album? Okay, but we have the ID, so how do we go and fetch the right object? Yeah, okay. So we'll return db.albums. We could try find. Oh, let's see. Let's try it. We'll find the object that matches that ID. Let's assess. So now if we just grab any one of the IDs from our list, and I've got an ID 685. If I just stick that on the end and run another GET request, see what it gives us. There we go. So there's our proper object with a 200 OK response. Okay. Now, this works, right? We didn't get any object because that ID doesn't exist. I would suggest we do want to modify this. What's the problem with this? It's workable, but it's not ideal. Right. What status code did it return? Right. 200 status codes are generally reserved for successful requests. So it's successful in the sense there's not really an error, but it didn't really work. So I don't think 200 is the right response in this case. What would be a more descriptive response when a request comes in, asks for a resource that doesn't exist? We have an HTTP code for that, 404. So we might want a little check here. And we should check whether that object is found or not. So let's maybe do this. So Luis, we'll keep the code you suggested. We'll see if it works, but we'll maybe just put that into a separate line. And then we'll evaluate if we got anything or not. So if our album is null, to return an HTTP 404, we can use the built-in, we can say it's not found. That will return a 404. The problem is our method is returning an album. So what happens when we don't have an album? So maybe what we want to do is make a more generic return type, because we might return an album, but we also might return a 404. So we'll actually use good old action result in this case. That will be flexible as a parent class. We can return either an object or a 404. So a return not found, or we can return, in this case, we can return OK as well as the object. So that will return a 200 status code and the object. So let's try this. We may have to use a different method, but I think this will work. If this doesn't work, we know single or default with the link query will work. So let's try this again now. If I put in a valid ID, we get 200. So in a GET request, the response will contain the entity requested. Good. It gave us album ID 685. In this case, that's what we want, right? That album doesn't exist, so we're sending back 404. So our documentation should include, these are the responses you get in this method. You'll either get 200 with an album object that looks like this, or you get a 404. So in your app, you need to check those two responses and display data to the user appropriately. So those are our gets. Right? So these are equivalent of our index and details methods. Anybody have questions so far? Yep, Hitesh?
What if you use single order?
It would work fine. Be the same thing. We just have to change, rather than ID, you need the lambda expression. But single, in my morning class, I use singular default instead of find.
Would there be any difference in the functionality?
Not really, no. No. So find only works with primary keys. Singular default will work with any link query. That's the difference. So that's kind of a shortcut to use find, because it zeroes in on just using the key value, which is indexed, and fields that are indexed are searchable more quickly. Good question. Okay, so now let's run a post, then we'll do a put, and we'll do a delete. Same URL, so we do not have a separate URL for any of these. Everything happens at APA/albums. We define this method as post. What should we return? If somebody can use a different program to send us an album and we want to save that to our music store database, what would be reasonable to send them back? Yeah, either if it's okay, we actually should send them not only okay, but we should send them the whole album object, because there's a new piece of information. What piece of information did that the client didn't send? What gets generated on our site that we'll need to send back? Right, the primary key. That doesn't exist until we save it in the database. So we'll send them back an okay response with the whole object that includes the ID. And if not, maybe we should take a look at the list of HTTP status codes. So instead of using 200, instead of using this one, which status should we send back instead that's more descriptive, Jacob? Yeah, let's send 201. That's the standard. We're creating a new resource. We'll send them back 201, and we'll give them the new album that has our ID. What if what they send us is no good for some reason? Like there's no title or the price is negative. Yeah, 400 is probably the most accurate description. They made a bad request. So we're either going to send back 400 or 201. So okay, constant is status teapot. All right, good to know. Yes. Okay. So because we might be, again, sending back a 400 bad request or a 201 with an object, probably best to use action result, our parent class, because that will give us the flexibility to return either one, either response. Method called post. From the request body, we'll try to save. So we're expecting an album object to be passed. So if our model state is not valid, so any of the validation rules are violated, title is blank, or the price is not within the acceptable range, we want to return a request. That will give us, that will send back a 400. But we don't only want to send back a 400, we want to send back information about what they did wrong. So in this case, we will send back the model state itself. This will contain all the validation errors. Title is required. Price must be between 0 and 10,000. Otherwise, we'll return a created at action. The name of the action is post, and we send back the album, and it will include, as Ali said, it will now include the album ID. You could wrap this in an else statement. I think I did in my code in the morning. We don't need the else, because if we have an error, we have a return statement here. The rest of the code doesn't execute. So why write an else with curly brackets when we don't need it? So now we want to try to create a new album. So we're going to need to set up a post request. For the get request, we don't provide any data. We don't have to send any JSON in the get. But for posting and for putting, we do. We need to actually provide a request body. So here's what I'm going to do. I'm going to change my get to post. I'm going to take out the ID. There is no ID. We're creating a new resource. And if you click on body in Postman and raw, and then change the content type to JSON, this will allow us to create and submit a JSON object in our post. I want to take out the ID. There is no ID. We're making a new one. Put in an album title. You're using my database, make up your own album title. Put your own name in it. Okay. Put in a price. And I'll put in, artist ID 1, genre ID 1. And then I'll try to submit my post request. If this is successful, we'll get a 201 response. And down at the bottom, we'll also get, zoom in a little bit, we'll also get the new album object that will include the new ID. So I'll try sending this request. So when I send, okay, that's not good. I got 201 with an album ID of 0. Well, that's interesting. Let's see what just happened. Why did we get a 0? Well, this is where we can use our API to check. I'll run a GET request. I don't think that's saved properly. Interesting. Okay, I did something wrong, clearly. My album didn't save, but it gave me 201, which is clearly not right. Go back to our controller. What do we do? Our methods post from the body. Oh, we didn't actually save to the database. Whoops. db.albums.add add our album and save. There, that might work better. That would probably help. I'll go try it again. Postman's nice. It'll keep my request here. So here's my afternoon album. I'll run my post again. It gives me 201. And now I have a new album ID of 694. If we want to be sure this is created, I'll now run a get. Make sure it's still here, which it is. What happens if I add an album that violates my model rules? So I want to do a post. No title and a negative price. We get a bad request. And we get a JSON object describing all of the validation errors. So that's what we're going to send back to our client, which is good. So put and delete are going to be pretty similar. The only difference with put is we'll need an ID parameter in the method. We'll need to change the method type from post to put. And instead of adding, we just mark the album as state as modified. Delete is identical to this. Instead of add, we call remove. We send back a different status code. And again, we have our parameters just an ID rather than the whole object. So these methods should be pretty simple to write. So we want to put, and we can't do an update without an ID. So our put method takes a parameter, an ID parameter, and we'll use an action result as a return type so we can return an error if that album isn't found, or some kind of success response if the update works. So first we'll check the model state. And check. We'll return a 400 with the validation errors. We get invalid data. If they take an existing album, wipe out the title, or take an existing album and change the price from a number that was valid to a negative. Now we can also do a similar check like we did in our get. Actually, maybe we don't even really need to. If they give us an ID that doesn't exist, we just update nothing. That's probably okay. But in this case, we just call we'll take the album state. We'll change the state to modified. I'll save. That'll do our update. And now we can look and see which HTTP status code we want to return for a successful update. I'd love to do Teapot. We could do 202. What's 206? Let's see. Good Lord, what does that mean in English? I don't think we want 206. Partial content. We could do accepted, perhaps. Let's see. Accepted for processing, but has not been completed. Intentionally non-committal. No, because we are committing to the database. So maybe 204, no content. We've fulfilled the request and there's no additional content. So maybe that one's good for update, a 204. Um, 204 says it's used for, yeah, typically response to a put request. So maybe we'll commonly use with document editing corresponding to a save. So maybe we'll use that one. So no content, yeah, that gives us 204. We can still, yeah, we don't have to, so this would be empty. Yep, we took it, successful. So there's our put. Just look up my album again. I think it was 694. So here's my new album that I just created. So now I'm going to do a put request. So you change get, put my title back in. I'm just going to change the price on sale, $9.95 to $8.95. So I want to try a put method, do an update. Sends me a 204 with nothing back. Now, how do I know it actually updated? Well, just run a get request. Now the price is $8.95. So this is actually how I'm going to test mark your assignment. I'm going to run the get method first. Then I'm going to grab one of the IDs, stick the ID on the end, and run another get request. Then I'm going to copy one of those JSON objects. I'll do a post, then I'll do a put, then I'll do a delete. So in the end of the day, you won't see any change in your database, right? I'll create an object, I'll update it, and then I'll delete it. So I can actually mark part 3 fairly quickly using Postman. So delete should be pretty easy here. And we need our ID parameter. So we're going to try to find the album. If we find it, we'll delete it. If we don't find it, we'll return a 404. So because find only works with primary keys, that's why we don't need a lambda expression. It already knows what column it's checking, which is the primary key column. Album is null. Not found. Otherwise, remove it. Save. Then we just need to figure out what status to return. There isn't the HTTP status explicitly for deleted. I'm not sure which one we want to use. Let's see here. No, we don't want that. Yeah, we might just return a 202 here as well. Oh no, but again, not completed. Intentionally not committal. So maybe we just want an OK in this case. The 200 will be OK for delete. There's no hard and fast rules here about what's the right status code. It's kind of up to the developer. We'll just return an empty OK response. We don't need to send any data back because the data has been removed. So it will return either 404 or 200. So now if I run a delete at album 694, I get a 200, and now my GET request should give me a 404 again, because this album should be gone. So now I get 404, so we know the delete worked. So there's our whole API. It's very lightweight, right? But we can do all of the CRUD operations with those 5 methods. So I'm not really asking you to reinvent the wheel for your assignment. I just want you to go and do this on your own with your assignment 2.
In the case of the port method, like if the ID doesn't exist, what will happen?
Nothing. It will, because it runs the equivalent of update album, set title equal to this, price equal to this, where album ID equals 1 million. So it just updates, tries to update a record that doesn't exist. So it doesn't throw an error, it just doesn't have any, doesn't make any actual modification.
Like yes, someone has a value, but doesn't find anything, so it will create that.
Oh,
Won't it receive
yes.
understand
It won't create it because we're marking it as modified. Unless you call add, it won't, and the entity framework won't create a new one. It's this, without calling add, this is only going to do an update if that object exists. Okay. We could check here. We could run the find first, just like in the delete. So we could add this code to the put. That would be fine. So, you know, return a not found if that ID doesn't exist. Nothing wrong with that. So if we wanted to first run the query, we'd need a different variable name because the album is the request, so we would need to use a different variable name. Otherwise, we're overwriting the new values.
So it would be like let's modify, not then add a new.
Well, you'd have to then write the code to do that. Right? You'd need an if statement like we had in our repository, right? If the ID is this, is 0, add, otherwise mark as modified and save. So you could do it, you could set up your API if you want it to work that way, you could. I'm just going to make it so that it only updates, and they send in an ID that doesn't exist, just nothing happens. Now, Visual Studio does allow you to scaffold these controllers as well, but I didn't think it was all that much code or that it was all that complicated. So I thought, based on the time we had, it was more useful for us to actually build the controller ourselves. I mean, we could have scaffolded one. I could just say new scaffold item, API controller with actions. It would actually give us a similar type of thing. We can look at it. It just calls the database connection underscore context instead. Now, this is also using asynchronous code with async and await. So in other words, you could call these API methods. We didn't really want to get into asynchronous code, which was the other problem with the scaffolding. Asynchronous code basically lets your code continue to execute while one operation is running. You'll learn more about this when you guys come back to school in May and you work with Node.js, because Node is based all around asynchronous programming. Okay? So it's fairly similar to what we did manually. So it's here. In your assignment, I would prefer, it's not that much code, I'd prefer you actually create the API controllers yourself so that you're kind of familiar with how they work.